Hello guys, my name is Bino, and in this video we'll be going through question 4 from the November 12, 2020 and for mathematics question paper. Question 4.1, we have to determine the limit of x cubed minus 8, all of which is divided by x minus 2 as x approaches 2. So we can immediately see that if we were to substitute 2 where there is x, so this will be 2 cubed minus 8, all of which will be divided by where there is x, we substitute 2 minus 2. 2 cubed is equals to 8 minus 8, 2 minus 2. So this will be equals to 0 divided by 0. So we know that division by 0 is not allowed. So instead of substituting directly 2 where there is x, let's try to use long division to divide this. So we are dividing x cubed minus 8 by x minus 2. So we have to use long division, but using long division when this is in this form is going to be tricky. So instead, let's introduce 0. So now we have x cubed plus 0x squared plus 0x minus 8. So we write this in standard form. So we have not changed the expression. All that we did is that we added the zeros. So 0x squared plus 0x is equals to 0. So we only added 0 into our original expression. So x cubed divided by x will be equals to x squared. And x squared multiplied by x will be equals to x cubed. X squared multiplied by negative 2 will be equals to negative 2x squared. X cubed, so now we minus, so we introduce that minus. X cubed minus x cubed will be equals to 0. 0 minus 2x squared will be equals to 2x squared. So negative minus negative is equals to 0. So from here, we bring down that 0x. So 2x squared divided by x will be equals to 2x. And 2x multiplied by x will be equals to 2x squared. 2x multiplied by negative 2 will be equals to negative 4x. And from here we minus again. 2x squared minus 2x squared is equals to 0. 0 minus 4x will be equals to positive 4x. And here now we bring the negative 8. So 4x divided by x will be equals to 4. And 4 multiplied by x will be equals to 4x. 4 multiplied by negative 2 is equals to negative 8. 4x minus, so we introduce that minus again. 4x minus 4x is equals to 0. Minus 8 will be equals to 0. So x cubed minus 8 divided by x minus 2 will be equals to x squared plus 2x plus 4. So the limit of x cubed minus 8 divided by x minus 2 as x approaches 2 is equals to the limit of x squared plus 2x plus 4 as x approaches 2. So instead of evaluating this limit, we evaluate this one. Instead of plugging the 2 on the left hand side, we plug the 2 on the right hand side. So where there is x, we substitute for 2 and we drop the limit. So 2 squared plus 2 multiplied by 2 plus 4. 2 squared is equals to 4. 2 times 2 is equals to 4 plus our 4. And this will be equals to 4 plus 4 is equals to 8 plus 4 is equals to 12. So the limit of x cubed minus 8 divided by x minus 2 as x approaches 2 is equals to 12. Question 4.2, we have to differentiate with respect to x. Y is equals to log 5x with the aid of the function of a function, also known as the chain rule. And we have to show all intermediary steps and substitution. So we have y is equals to log of 5x, and the instruction is for us to use the function of the function or the chain rule. So what they want is for us to say let u equals to 5x, and after here to determine dy over dx, we have to multiply the derivative of y with respect to du with the derivative of du with respect to x. So that du will cancel out with that du, and this will be equals to dy over dx. But let's do it. So we have, so where there is 5x, will substitute for u. So this will be equals to y is equals to log of u. So we differentiate u, or we differentiate this y first. So let's start with the u. So du, we differentiate it with respect to x. The u, we differentiate it with respect to x. Du over dx is equals to, so the derivative of 5x is equals to 5. So now we have to differentiate this y with respect to u. So dy over du, so the derivative of log of u will be equals to 1 over u multiplied by ln 10, which we can also write as 1 over x, 1 over u, 1 over u multiplied by log e. So it's either you use 1 over u ln 10, or you use 1 over u log e. So to determine dy over dx, we simply have to multiply the du over dx with the dy over du. So dy over du is equals to that 1, and du over dx is equals to that 1. As I already said, that du is expected to cancel out that du. So du over dx is equals to 5, and dy over du is equals to 1 over u ln 10, or this we can also write as 5 multiplied by 1 over u multiplied by log e. But we know that u is equals to 5x, so let's bring back the 5x in the place of u. So where there is u, now we substitute that 5x, because 5x is equals to u. So this is supposed to be ln 10. And if you choose that other side, this will be equals to 5 multiplied by 1 over 5x multiplied by log e. That 5 will cancel out with that 5. So dy over du is equals to 1 over x ln 10, or it's equals to, that 5 will cancel out with that 5, or it's equals to 1 over x log e. So it's either you will choose this side, or you will choose that side, based on dy over du being 1 over u ln 10, or dy over du being 1 over u log e. Question 4.3, we have to differentiate with respect to x. Y is equals to cos of x divided by ln x with the aid of the quotient rule. So let's first define our quotient rule. So if you have y is equals to f of x divided by g of x, the derivative of y with respect to x will be equals to the derivative of f of x multiplied by gx minus the derivative of gx multiplied by f of x, all of which will be divided by g of x squared. So we are differentiating y is equals to cos of x over ln x with the aid of the quotient rule. So this will be equals to, so the derivative of cos x, each and every time when you differentiate something which starts with a c, you always get a minus sin x. So the derivative of cos x is minus sin x, which we will multiply with ln x, and the derivative of ln x is equals to 1 over x, which we are going to multiply with cos x according to the quotient rule. And all of this will be divided by ln x squared. So this will be equal to negative sin x ln x minus cos x over x, all divided by ln squared x. But I think that if you were to leave your answer in this step, you will still get your full marks. Question 4.4, we have to differentiate with respect to x. Y is equal to negative 1 over 2 cot x minus the square root of 2 cos x plus 1 over 3 log 7x plus tan 2 theta. So dy over dx will be equals to negative 1 over 2. Like I said, each and every time when you differentiate something, a trigonometric function which starts with a c, you always get a minus. So the derivative of cot x is equals to negative cos x squared x minus the square root of 2. So when you differentiate something which starts with a c, you get a minus. So the derivative of cos x is minus sin x plus 1 over 3 multiplied by the derivative of log 7x, which will be equals to 1 over 7x multiplied by log e. And according to the chain rule, we also have to differentiate the inner function 7x. So the derivative of 7x is equals to 7. So log e 1 over 3 multiplied by 1 over 7x multiplied by log e multiplied by 7, which is the result of differentiating the 7x, plus we are differentiating with respect to x and not with respect to theta. So this tan theta is not attached to any x. We treat it as a constant. So the derivative of tan theta is equals to 0. So we have dy over dx. So if we were differentiating with respect to theta, then the derivative of tan 2 theta was going to be 2 sec squared 2 theta, but now we are differentiating with respect to x. That's why the derivative of tan 2 theta is equals to 0, because there is no x attached to it, or there is no x in the inner function. So negative multiplied by negative will be positive. Cos x squared x divided by the 2. Negative multiplied by negative will be positive. The square root of 2 sin x, that's 7, will cancel out with that 7, and we'll be left with log e divided by 3x plus 0. So this will be the derivative of y with respect to x. Question 4.5, we have to calculate the coordinates of the turning points of y is equals to x cubed minus 9x, and we have to distinguish between the minimum and maximum turning points with the aid of the second derivative. So let's first focus on the first part of the question, where we have to determine the coordinates of the turning points of y is equals to x cubed minus 9x. So to determine the coordinates of the turning point, we have to differentiate y and equate it to 0. So we have y is equals to x cubed minus 9x. So the derivative of y will be equals to the derivative of the x cubed, which will be equals to 3x squared, minus the derivative of the 9x, which is equals to 9. And we have to equate this to 0. So 3x squared minus 9 is equals to 0. So we solve for x in order for us to determine the x coordinates of the turning points. So let's divide through by 3. So that 3 will cancel out with that 3. X squared minus 9 over 3, which is equals to 3, is equals to 0 divided by 3, which is equals to 0. So we are solving for x so that we can get the x coordinate of the turning point. And after getting the x coordinate, we take the x coordinate and we substitute it into the original y equation and not this derived equation. So we take the negative 3 to the right, is going to change sign from negative 3 to positive 3. So let's solve for x by introducing the square root both sides. What you do on the right, you also do on the left. And when you introduce the square root, you have to include this plus or minus. So that square root will cancel out with that square. So x will be equals to plus or minus the square root of 3, which we can write as x is equals to the square root of 3, or x is equals to negative the square root of 3. So let's determine the corresponding y values of the x's. So in order for us to get the corresponding y value for x is equals to 3, we take this x is equals to 3 and we substitute it into the original y equation, x cubed minus 9x, and not this derived equation. So where there is x, we substitute the square root of 3. So y will be equals to the square root of 3 to the power 3 minus 9 times the square root of 3, which will be equals to negative 6 times the square root of 3. So when x is equals to the square root of 3, y is equals to negative 6 times the square root of 3. And this will be our first turning point, which we can denote as turning point 1. So to get the corresponding y value for x is equals to negative the square root of 3, we simply have to take this negative the square root of 3 and substitute it into the original y equation. So where there is x, we substitute negative the square root of 3 cube minus 9 times negative the square root of 3. So y will be equals to negative the square root of 3 cube minus 9 times minus the square root of 3. And this will be equals to positive, so y will be equals to positive 6 times the square root of 3. So when x is equals to negative the square root of 3, y is equals to 6 times the square root of 3. And this is our turning point number 2. So we can write this. So we have 3 times, so we have the square root of 3 minus 6 times the square root of 3, and negative the square root of 3 and positive 6 times the square root of 3. So we have dealt with the first part of our question. So in order for us to distinguish between minimum and maximum turning points, we have to use the second derivative. So the first derivative was, so the first part and the second part. So we have the first derivative as y is equals to 3x squared minus 9. So we have to differentiate this for the second time. So y double prime will be equals to the derivative of 3x squared, which is equals to 6x. And the derivative of this negative 9 will be equals to 0 because it is not attached to any x. So in order for us to distinguish whether this one will be minimum or maximum, or whether this will be minimum or maximum, we have to focus on the on the x value. So we take the x value from both of our turning points and we substitute them into the second derivative. Where there is x, we substitute the square root of 3, and where there is x, we will substitute negative the square root of 3. So if y double prime is greater than 0, then this will be a minimum. And if y double prime will be negative, this will be a maximum. So the coordinate of that x will be a minimum and the coordinate will be a maximum. So let's substitute. So we have y double prime. We first substitute the square root of 3 where there is x. So this is 6 times the square root of 3, and this is greater than 0. So the coordinate, so this coordinate will be a minimum because y double prime is greater than 0 after we substituted the x coordinate. So now we have y double prime. So let's substitute negative the square root of 3 where there is x, and this will be equal to negative 6 times the square root of 3, and this value is negative. So this y, so this coordinate which has the x, which has this x will be a maximum. So we substituted x and we got a value which was less than 0, so it was a maximum.